Permutations, order matters. So like license plates, words, numbers, codes, picking people from a group, and then giving them specific jobs. Bless you. Now, this one here is a combination where order doesn't matter. So here it says, discuss how throwing 3 toys in a bag is different than lining the 3 toys up. Well, this is how it is. 3 toys.
Oh, I thought you were going to throw them on the floor.
Yeah, I thought I was throwing my face. He was like literally, but I wasn't. I don't even know where you went that route. I was just. How many ways can that happen, Lucas? You wouldn't even friggin' know. You were on your phone.
Yep.
Put that thing away. Lock it up. Okay. 3 toys. Throw them in a bag. For you. So many things to be said. Okay. How many ways? How many ways?
6. A lot of ways.
Infinite.
1. I just did it. That's it. 1. Here's the 3 toys. No, the 3 toys, and I just put them in a bag.
Nope.
Like, I freaking acted it out, people.
Yeah, see, there's another in this position.
1.
No.
If you shake up your bag, then you don't come back.
1. Still in the bag.
Because they're in different positions.
1. I am not lining them up. I don't give a crap. I'm taking the 3 toys, and I'm like, hey, I gotta go home. Did it make it any pretty different? Oh, wait. You're right. The toys are totally different now. Yeah.
Yeah.
You're not. It's one freaking way. Yeah? Okay, but if I line them up, this is where you guys were. If I line them up, what happens?
They're in a line. They're in a line.
So many different ways, right? Because you can see them. Because they're not just put in a bag and taken home. I'm lining the toys up. So lining the toys up where you can actually see them is a permutation more than one way. Take them, put them in a bag, one way, okay? Now, how many ways could it be if I actually lined them up? I'm not lining anything up in a bag. That's just weird, and I don't know why you're doing that. Stop it. Okay, you're lining them up to see your toys, because kids do that. What would I have for an option for this spot? What would I have for an option for this spot? 3. Then what happens? I leave a toy. So then I leave a toy. So now there would actually be 6 options if I lined them up. Now that is a permutation. But if I take all 3 of them and I just toss them in a bag, one-way combination. It's the same thing if we talked about library books. Okay? Say you suck and have not returned your library books. You're going to have to do that. Yes. Okay, so you're those people. You didn't return them. Let's pretend. And it's second semester, okay? And your librarian says to you, okay, I don't want to stop your reading. I don't want to crush your reading, goals. I don't want to crush them. So instead of letting you take the 3 books home that you want to read, you can take home 1, return it, take home another, return it, take home another, and then you have your 3 books. Okay? Does the order matter that way if you can only take 1 book home at a time? Yeah. Because if you want to read a series, you don't want to read it backwards. That's exactly it. You have to read the 3rd book first, the second.
If the question was ambiguous, that was not mentioned in the question.
And you should have been able to do this first.
Yeah. Thank you. Exactly. Inferring. Yeah, the inference that was there. You did not pick. Oh, but it's okay. So, if we could take home 1 book at a time, we'd have 3 options for the first taking out of a book, right? Then we'd have 2, then we'd have whatever we didn't read. Hopefully the 3rd book in the series, because that was actually a amount of work. Now, hopefully this solidifies the taking it in your bag and going home. You're a good standing child. You have returned all your books. The librarian actually likes you. She likes the other people too, but you have a little bit of a against you. She's like, you can't return your books. It's not that hard. Anyways, side note. So if I went to the library and I was in bad standing, or good standing because I'm really awesome, And they said I could take all 3 books out at once. How many ways could I do that?
At least one.
One. I take the 3 books, I throw them in my backpack, and I walk home. There we go. There's my one way.
I was right.
You're taking home the book. If you take, it doesn't matter. The books are in the bag. One book. They didn't say your bag was the size of your purse. I don't even know why I picked one. Okay. So, the formula for that would be a combination, would be with a C, because it is a combination because order doesn't matter. So if you go 3C3 in your calculator, put that in. You're going to go 3, then you're going to go math, and then you're going to go 2 above, I think it's 2, maybe it's 1, above the factorial symbol that you know where to find. So math over to probability, and you're going to pick C. It's, yeah.
And is it 1?
Yes, it should be. This is, I went to the library, I took out 3 books, I went home. One way. This 3P3, type that one in. This is a permutation. So I have 3 books, and I take them out in an order. You'll see in about 10 minutes. Because you have 3 books, and you're putting 3 of them in order. This one I'm taking 3 books, and I'm just choosing 3 books, and I'm taking them home. This is a permutation where these 3 are ordered. So this is how many you're choosing from. This is how many you choose.
So the first is how you run it. The second is
Right. Right. So if you had 7P4, that would be the same as saying I have a 7-letter word and I'm arranging 4 letters. Boom, 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 which would be 7 times 6 times 5 times 4, which these are actually the same answer. So if you ever start at a number and go down by 1 each time, you can use this formula. So if I went like 8, 7, 6, 5, let's say 4, this is the same as 8P. How many did I choose? 5. Because I have 5 blanks, right? I picked 5 letters. They're equivalent. They would get you the same answer. Which one's better? I don't know. Whichever one you get. Okay. Now, the formula for P is NPR equals n minus r factorial over n, yeah. N over n minus r factorial. So your calculator, every time it's doing this formula in it, it's doing this. So if you put 8p5 in your calculator, it's going 8 factorial over 8 minus 5 factorial, which is technically 8 factorial divided by 3 factorial, which is an answer that matches this one. I don't know what that is. But they're the same. Because this is your n, this is your r. You're literally just filling it into the formula. Now with the C formula, it has a difference. It goes NC, that's actually just up here. NCR equals n factorial over n minus r factorial, r factorial. So the only difference is it's a division of r factorial, extra. Do you see that between the p? And what happens when you divide by a factorial? You're getting rid of what? Why do we divide by the factorials on our board over there? Get rid of the repetitions. Get rid of the options. Exactly. So we're getting rid of all those cases where we would arrange them and order them because we're not ordering them. It's a combination. Okay? Now, just so you know, type in 10C6. Type that into your calculator. 10C6. What do we get? 2 10s? Okay, type in 10C4. What do we get? 2 tens. These are actually equal. Now why? Everyone paying attention. You don't have to write this down, I'm just explaining why. So if I have 10C6, and I go to fill it into the formula for NCR is NCR equals n factorial over n minus r factorial. So n and r, so I would get 10 factorial over 10 minus 6 factorial, which is actually the same as 10 factorial over 4 factorial, 6 factorial. Okay? Now, I said it's equal to 10C4, so that would be NR. So it would be 10 factorial over 10 minus 4 factorial, which is 10 factorial over 6 factorial, 4 factorial. What is the deal with 4 factorial, 6 factorial, and 6 factorial, 4 factorial? They're the same because multiplication is putative. It can move around, right? So, it only works for C's because there's the r factorial after it. And what rule could we make here? So 10C6 is the same as 10C4. Why? Yes, 10 minus 4 is equal to 6, and 10 minus 6 is equal to 4. And that's how you're getting these ones that match, right? So the rule on the previous page, on the one that you guys are on, is NCR is actually equal to NCN minus R. So an example could be if I give you 20C16, that's the same as 20C what? 4. Just the difference. If I give you 5C2, that's the same as saying 5C3. It only works with C's. It does not work with T's. And it's because it has that r factorial. So it's the common difference between the two. So here it says 3 students from a class of 10 are chosen to go on a school trip. In how many ways can they be selected? Does it are those 3 people any more special if they're picked first, second, or third? No, they just get to go on the trip or not. That's it. So it is a C. If the 3 students who were going on the trip got to go on 3 different trips, then it would be P. Or they had 3 different jobs on the trip, then it would be a P. Okay? But if 3 people just get to go on the trip, if you're picked first, second, or third, you go on the trip. You're not any more special than the other one. So I would go 10C3. There's 10 students. I choose 3 to go on a trip. I picked a C because order doesn't matter. What is 10C3? How much? 120. And it's the same as actually saying 10C what? 7. Okay? Then we flip over. Okay. The next one is to win the Lotto 649, a person must correctly select 6 numbers between 1 to 49. The key thing is that you don't have to pick them in a specific order. So you go to your ticket, you have 1 to 49, you could bubble numbers, whichever ones you want. And basically, those 6 numbers out of 49, so I thought of 649, have to come out. They don't have to come out in the order you pick them, because you're going to pick them in numerical order, because that's what the little sheet is in, is numerical order. If you had to pick them in actual order of what the numbers popped up, it would be almost impossible to win the lottery. It would be pretty much impossible if you had to also get them in the same number, same order. Yeah.
Do they actually pick the winning number set, or do they just randomly throw out numbers, and if nobody has that number set, they don't?
I'm sure I think it's actually it's a random pick, but it's like a machine who did it. And back in the day, it used to be like 6 balls would pop out of this thing. You know, one of those things. And then it would, space, and it would just go, and you'd be like, 6, 5, I only know because of watching it on old TV shows, not because I actually watched that.
I believe you.
Okay. All right. Here or there. So, how many numbers do we get to choose from? How many numbers do we get to choose from?
49.
49. And is it a C or a P? It's a C because I told you order doesn't matter in which the 6 numbers get picked out. You just need to have those 6 numbers, correct? So if your number was like 7 and 4, and then 4 and 7 popped out, it wouldn't matter. Yeah, I have both of them. Great. It's like a bingo card, right?
And is this for actual lotteries and how many you get all of them? Or just
All of them to win it. If you get like 5 right, you win some sort of money, but I don't know. I literally don't play the lotteries. I'm not the best person to be asking this stuff. I do know you need all 6 to win, and I do know if you have a varying number of like, I think 5 and 4, you win certain things. Like maybe if it's 4 numbers, you win like a free play or something. I think if it's 5, you win like sometimes like 5,000 or 10,000. So like it sounds like it's really awesome, but like the lottery will be like, I don't know, 40 million, and you're like, you got 5 numbers and you win like 5,000. So close, but not yet. So far. Okay, I wouldn't like scoff at the 5,000. I'd take it. There's no problem. Okay, what's 49C6? 49C6 is a really large number. What is it? So you technically have a 1 in 13,983,816 chance of winning. So people would say, well, why don't we all 13,983,000? Because a ticket, I don't know, it's like 10, 20 bucks or something like that. 10?
No, it's.
It's 4 for like just one line of it?
Yeah.
Yeah, so you'd have to do, he's way better at this than me. So if you went to just win the, he is. He's 18.
I work in December.
you immediately started doing
I work in customers.
He knows. Okay, we don't need to know why he knows. He has knowledge. We're just going to go with it. Okay, so it costs, if you think about it, it costs $4 a ticket for one line. You would have to, this is almost 14 million, right? So it'd be 14 million times 4 for everyone to just win $1. Like, so you would not even make back your money. So that's a problem. Okay, so that's why people don't, they're like, why don't we just play the thing? It's not going to happen. Also, just because 6 numbers are picked doesn't mean they can't be picked again, right? So sometimes no one wins the lottery for a long time, and then sometimes 10 people win the lottery. Because they all have the same numbers, they have to split it. I'd be also okay with that. I'd split whatever money. I wouldn't mind. Okay. So, let's look at this next one. Example 3. The athletic council decides to form a subcommittee of 7 council members. That's important. No matter what, we're going to have to choose 7 council members to look at how funds raised should be spent on sports activities in the school. Okay, they want to pick 7 people. Now, if they give those 7 people jobs, it's a P. If they just pick 7 people and they're part of the subcommittee, it's a C, because order doesn't matter. That's what we're always going to look for when it's a committee. When it's a committee, we look, do they have jobs? So are the 7 people any different? If they're different, then it's a P. If you just pick them and put them on the committee, and they're just on or they're not, it's a C. So here it says there are a total of 15 athletic council members. There's 15 total, so that's how many I'm going to get to choose from. 9 males, 6 females. Now here it says the subcommittee must consist of exactly 3 females. So I know I have to pick 3 females. That's great. But how many people do I need on this subcommittee? 7. So what does that indirectly tell me? And 4 males. It's not or, it's and, because if it's or, you have either 3 or 4 people, and I need 7. So I need and. 3 females and 4 males. So if I was choosing like teachers and I was choosing students to go, the only way I could guarantee getting teachers is choosing them from teachers. And getting students is choosing them from students. So how many females did I give you? 6. And did I give them any jobs? Anything in here, any jobs? No, so it's a C. And how many am I choosing? 3. And males, how many? 9, and I'm choosing 4.
Why is it the
Why is it 9?
same? No, like multiplying.
Because it's and. If it's or, you'd only have 3 people or 4 people on the subcommittee, and I need 7, so I need an and. So type it in. What do we get? B factor. Okay. What I'm going to have you do is you're going to go on to Google Classroom, and I'm going to post another couple reviews.